wait a few minutes, see if we gain by watching. I had just got off the phone with Joe Shearer just a little bit ago. In a Hangouts one night, we were talking about a circumference square, or circumference rule, sorry. And I was trying to explain it to him, and trying to explain to someone who's never seen one or used one how they work is a little bit tough. So I told him that you know, I'd do a real short video on it. So, but anyways, I'll go ahead and start here. This is a circumference rule. And I know it's backwards because the camera's backwards, so bear with me here. So it's 48 inches long, and as you can see, there are numbers that appear almost to be in a metric scale underneath the standard scale, but they are not metric. And if you read that, of course it's backwards. It says circumference inches in eighths. So what that means is, for those of you who don't know, if you take the diameter, say you've got a piece of duck and you need to make a collar for it, or square it around, you need to make a collar, and let's say it's 16 inches. I know Joe said that's a very common size for him. Well, one way to do it is you take 16 times 3.14 and then add your lap or allowance for that. Well, with this, you don't have to do that. What you do is you take a square, you line it up on 16 inches, which is the stretch out, which means with no allowance for a lap, would be round about 50 1/4 inches. And I'll show you how that works here. So you take a square, okay, and then you go over to 16. Alright. Now, you see on the bottom one, it's on the 1/4 inch line. Well, if you slide that back, that's 50 1/4. Okay? So just to confirm that, we'll get out the ITI calculator, the sheet metal calculator. So what we'll do is we'll take, there, now you guys can see it. Okay, so we'll turn it on. Alright, so we'll take 16 and we'll hit the inch button, and then we'll hit circumference. That's 16-inch diameter, circumference. Oh look, 50 1/4 inches. And we hit circumference again. Area of that circle, or of that, is 201.069 inches. Hit it again, we go back to diameter so we can go through those. Alright, now we can even take that and convert. No, that's not going to do it. I know there's a way to convert that back to a fraction on here, but I hardly ever use that. So there you, now you take that. Let's go back to this here, just so you can see it a little bit better. Do this without knocking everything over. So 50 1/4, roughly 16. So if you want to do a 1-inch lap, you just add an inch to that. So you would do 51 1/4 inches. So what you do is you'd cut your piece however long by however tall, add an inch, scribe a line, rivet it, spot weld it, whatever. So I'll show you guys kind of how I do it. My battery's low, so if I get disconnected, you'll know why. So let's do a 12 inch. So 12 inch is going to be not quite 37 1/4. So let's double check that. 12 inches, circumference. .37 11/16. So that's pretty close, you know. So depending on whether you want this to go over or inside a piece of pipe, and also depending on whether the pipe you're using is spiral or whatever, you can kind of adjust that a little bit. So 37 11/16 plus an inch should be 38 11/16. Tape measure. What do we got here? Oh yeah, we got plenty. Plenty. So 38 11/16. Let's see. Make sure I get out here to the edge. So we mark that. We'll square that line up. And I like to use a 1 inch wide rule, because then all I have to do is come back on the other side of it, and I've already got my 1 inch line. Come over here. Actually, this is a little bit heavier, so let's roll it. You can do this by hand. I was rolling some fairly heavy stuff in here the last time. So I'm going to line that up on my 1 inch mark. Normally I'd put my 1 inch mark on the outside, but I was kind of in a hurry there. And this is the scribe I use. I can get it to focus. Maybe not. Anyways, it is a Wimco, W-I-M-C-O, Wimco scriber. So what we'll do is we'll set that as 1 inch. Scribe 1 inch right there. Plug that in. So there we've spot welded it on our 1 inch line. We've got our crimp on it. So we came out just a little bit big on that end, which it's easier to check these with two hands so you can hold it round. It's a little bit oval shaped at the moment, so let's see what we got here. Try to hold everything in the right spot. I can get the camera to pretty close to 12 inches there. So anyways, using a circumference rule, I use it for more than just circumference. I use it to lay stuff out because it's so accurate. And the reason I say that, it is exactly 48 inches from one end to the other. So you don't have, like on some cheap rules, like say this one right here, of that, how they're from the start of the 1 inch line, there's another little bit of ruler there. Well, on this there is not. It is exactly 1 inch from the end to the 1 inch mark. So for laying metal out, it works great. So anyways, Joe, I hope that helps you. I hope that makes sense. I would watch this calculator I showed you guys and some of the union guys that watch this. I got that calculator when I was in the apprenticeship program. I have seen them on eBay for sale. So watch eBay. It is a International Training Institute sheet metal HVAC Pro. It will do run rise calculations. It will do there's even stuff on here for doing fan and horsepower calculations. Use fan law to do fan calculations, fan blade size. It will do all kinds of stuff, more than what I am capable of using it for, but it's a great calculator. Now, this same company that produces this calculator also creates calculators that do a lot of the same things, but don't have some of the bells and whistles, and they're available to the public. So I hope you guys like this. I'm going to do some more like short, sweet little sheet metal tip trick videos coming up. So like this one, we're running about 15 minutes. So let's look at the chat here. Nothing's popping up. I didn't know if anybody might have a question or something. So if anybody has a question that's watching at the moment, well, we just lost one viewer. So we're up to 3 again. So if anybody has a question about using a circumference rule or anything like that, let me know. Also, I'm going to go back. There's some... Focus. There's some different measurements on the back. That is flaring liquid measurement, quart, gallon, flaring dry measurement, cans pitch top. Let's see. It's not. Yeah, anyways. But there's some measurement stuff on the back for figuring some things out. So not something you'd use every day, but you might use it. Like for instance, it gives, say, straight dry measurement, 1 quart. And then it says 5, and then 3 7/8, or sorry, 7/16. So if you created a can, or basically a can that was a 5-inch diameter with a height of 3 7/16 inches, it should hold 1 liquid quart. Same thing with 2 quarts, 4 quarts, 8 quarts. Now bushels, it even gives bushels. So if you want to hold 1 bushel, it would be a diameter of 13.5 by 15 tall. It also gives you, let's see, we've got 1 gallon. Or see, one gallon contains 231 cubic inches. 1 bushel contains 2,150.4 cubic inches. 1 gallon of water weighs approximately 8 1/3 pounds. So, you know, I don't know how often I've ever used that stuff, but like I told Joe on the phone, and let's say you're known for doing sheet metal work. Say somebody comes to you and says, hey, I need a fuel tank for my drag car. I need it to hold 3/4 of a gallon or 1 gallon or whatever to run a 1/4 mile. And say that where they need it is kind of an odd shape. Well, you can use those measurements and actually build the fuel cell to hold what they need. So that's kind of where if you're doing a lot of like heavy sheet metal stuff, a lot of sheet metal stuff, you could do something like that with that information. So all right, hope you guys enjoyed it, and everybody have a good week.